Okay, so here's a continuation of our review. We're on page 5 right now. What are the roots to the equation? And again, let's remember, roots mean solutions. Also means zeros in this case. Okay? So when we talk about roots of a quadratic, we're talking about the solutions to a quadratic or the solutions. And remember, what makes this a quadratic? Anything in the form y equals ax squared plus bx plus c, where you have that x squared term. Okay? So we have this and we're trying to solve it. Anytime we're trying to solve something that has an x squared in it, you should be thinking about factoring. So when we take a look at x squared minus 10x plus 21, and we look for the GCF, there isn't one, no greatest common factor. It's not the difference of two perfect squares. So this goes down to a quadratic. Quadratics we try to break up into two binomials. Since it's just a plain old x squared, we have x and x. We take a look at the last number. If the last number is positive, it means the signs are the same. So it's either both plus or both minus. This tells us they're both going to be minus. And then we're looking for factors of 21, and since the sign's the same, they're going to be adding up to be 10. That's 7 and 3. Once we have it factored, we take each factor, x minus 7, and set it equal to 0, x minus 3, and set it equal to 0. And then we solve these two simple equations. And we get x is equal to 7 and x is equal to 3. And that's going to be choice 3. We move down to 15. Now 15 is a word problem. When we take a look at this word problem, we want to make sure that we look at how it's written and what it's looking for in terms of total. In this case, it's money. It's not total number of coins, but it's money. So we're going to have to change things to money. It says Rhonda has $1.35 in nickels and dimes in her pocket. If she has 6 more dimes and nickels, which equation can be used to determine x? And if you take a look at the choices, x is going to mean, and it's the only variable, and it's going to mean it represents either the dimes or the nickels. If you take a look, we have 6 more dimes than nickels, and we've said in class, anytime you have one quantity referring to another, it's dimes are being compared to nickels, so we're going to let x equal the number of nickels. And once we know what x is, in this case the number of nickels, it says that Rhonda has 6 more, which is x plus 6 dimes. 6 more dimes than nickels. Since we talked about this being a total amount of money that she has, we have to change all this to money. If I have x nickels and each nickel is worth 5 cents, I have to take the number of nickels I have and multiply it by 5 cents. We're going to add that. This is the number of dimes we have. Each dime is going to be worth 10 cents. And x plus 6 is the number of dimes I have, so I'm going to multiply that by 0.10, and that's going to equal the total amount of money I have, which is $1.35. And if you take a look at your choices, that's going to be choice 2. Question number 16. Question number 16, we have a parabola, and in this question they talk about, this time it's the axis of symmetry. We have to remember that a parabola written in standard form is your quadratic, ax squared plus bx plus c. And we also have a formula for the axis of symmetry, which is minus b over 2a. We're not going to be able to use the formula in this problem only because we're not given the equation for the quadratic, we're given the graph. But the one thing that is really, really important that can make the multiple choice question easier for you is the fact that if you know that the axis of symmetry of a parabola is x equals, right away you can cross out 2 choices. Okay? Now what is the axis of symmetry? It's going to be a vertical line that goes through the turning point of the parabola that splits the parabola up perfectly in half. In other words, a vertical line that you can simply fold the parabola right in half on top of itself. All right? And that's going to cross the x-axis at x equals a -3. And that's going to be choice 2. Moving on to page 6. We're going to get into this question number 5. Again, it looks difficult when you start taking a look at the graphs, but it's really not. Just use some common sense here. Antoine leaves a cup of hot chocolate on the counter in the kitchen. Which graph represents the change in temperature in his hot chocolate over time. So if you leave hot chocolate on the counter, common sense tells you that it's going to cool, and it's going to continue to cool. So the temperature of the hot chocolate when it's cooling is decreasing. So you're only looking at graphs that are decreasing. So this one is a good graph to check out because it's decreasing. This graph is a good graph to check out because it's decreasing. These two graphs don't make sense because this one says it decreases until it hits 60 degrees, and then for some reason it begins to increase in temperature. If you leave hot chocolate out on the counter, it's not going to increase in temperature on its own, so that's gone. And this graph as well, this graph tells you it's going to decrease to 0, which means it actually freezes and then comes back up and heats up again. So this graph doesn't make any sense either. And of the two remaining graphs, let's talk about this one. For the same reason as this one doesn't make any sense, not for the reason that it increases, but this one starts off at like 200 degrees and then decreases all the way to 0. Hot chocolate, if you leave it on the counter, will not go below a certain temperature. It definitely won't freeze. So you don't have to worry about this graph. It doesn't make sense because it won't freeze. I'm going to throw this one out. This is going to be the graph that we're going to look to as our answer. Question number 6, we have a proportion, and in this proportion we are going to solve for k, and when we deal with a proportion we simply have to cross multiply and set the results equal. So it's 3 times k plus 4 is equal to 2 times k plus 9, and then when we distribute we get 3k plus 12 is equal to 2k plus 18. Subtracting 2k from both sides, we get k plus 12 is equal to 18, and then subtracting 12 from both sides, we get k is equal to 6. And that's going to be the solution. Sorry, it went below the line there. So we'll go through it again. K plus 12 is equal to 18. When we subtract 2k from both sides, subtracting 12 from both sides, we get k is equal to 6.